So let's have a look at some of the classes that N-Audio uses as the base classes for components in a signal chain. We'll start with WaveStream, which was the first one to be added to N-Audio. WaveStream derives from system.stream, which you may already be familiar with if you've used file streams or network streams in .NET. WaveStreams are read-only. You can read from them, but you can't write to them. Because they inherit from system.stream, they bring along several methods and properties that are part of system.stream. The most important of these are the length and position getters and setters, and the read method. The length getter tells us the number of bytes of audio contained in this audio stream, and the position property tells us where we're up to in this stream, also in bytes, and allows us to set our position in bytes. Now it's worth pointing out that not all streams know what their length is or allow you to reposition. For example, if you're recording audio from the sound card, you don't know how much you're going to get, and you can't reposition. It's a constant stream of audio coming in. So WaveStream tends to be used as the base class for things like audio files, where the length is known in advance and where it's possible to reposition. Then there's the read method, and this really is one of the most important methods on all signal chain components. This is where we get audio out from the signal chain component. And it works just the same as the read method that you're already familiar with from the .NET framework. You pass in a buffer that you would like the audio to be written into. You tell it the offset within that buffer that you want the audio to be written to. This will almost always be 0. And finally, you tell it the number of bytes that you would like to be written into your buffer. Then, the read method will try to fill up the buffer with the number of bytes you've requested, and it returns the number of bytes it actually wrote into the buffer. This will normally be the same as count. It should never be more than count. And if it's less than count, then that should indicate that you're at the end of the audio stream. In fact, if you receive 0, you know you're definitely at the end of the wave stream. WaveStream also adds a few more properties on top of the ones found in system.stream. The most important is the WaveFormat property. There are many different ways of representing audio data, and so if you just read audio data out of a stream, you can't do anything meaningful with it because you don't know what its format is. The WaveFormat structure explains what type of audio you're dealing with. Is it PCM or compressed? Is it floating point or integer samples? What sample rate is it at? How many channels are there? All of that information is contained in the WaveFormat structure. There are also two helper properties. Current time allows us to get and set our position in terms of a time span instead of a number of bytes, which is more convenient to work with. And total time returns the length of the stream, again in terms of a time span, rather than number of bytes. All it's doing under the hood is using the average bytes per second from the WaveFormat to convert between time and bytes. In N-Audio, the WaveFormat class is the class used to describe the format that the audio is stored in. It contains a number of useful bits of information. The first thing is what encoding are we dealing with, and this is represented using the WaveFormat encoding enumeration. The most common two values that this will have will either be PCM or IEEE floating point. But if you're dealing with compressed audio, then it can have any one of a large number of different compression types set here. It also includes the sample rate, the number of bits per sample, or the bit depth, and the channel count. Finally, it also tells us the bit rate, which in the WaveFormat structure is actually in terms of average bytes per second, so multiply it by 8 to get the bit rate. And there's also the block align property. This is very important if you're repositioning. You should never reposition a wave stream to a position that's not a multiple of block align, or you could end up with corrupted audio. The WaveFormat class is actually based on the Windows WaveFormat EX structure, and N-Audio includes a number of derived types from WaveFormat to represent different compressed audio waveformats. Most of the time, however, you'll only need to deal with this base class to get the information that you need.